Most people are aware of the fact that amino acids are the constituents of protein. What your body needs is not protein, but amino acids, because when you ingest protein, the protein is converted into amino acids through a digestive process involving digestive enzymes. Of course, amino acids are the main elements involved in building muscle. They have an anabolic effect. Amino acids are generally categorized into two different categories, which is essential amino acids and non-essential amino acids. The essential amino acids, including the branched chain amino acids like isoleucine, leucine, and valine, these things are required to build muscle. To build muscle, you have to have essential amino acids. This is what makes protein supplements such as whey the better sources of protein, because they're rich in essential amino acids. Also, animal protein foods are richer in essential amino acids compared to plant foods. This is the reason why, generally speaking, animal foods are considered more anabolic or better muscle builders compared to plant foods. And you would have to consume a lot more plant foods to get the necessary level of essential amino acids to promote muscular growth. This term unessential amino acids is kind of a misnomer. I'm going to talk more in depth about this in an upcoming issue of my Applied Metabolics newsletter. But in the meantime, I wanted to single out or discuss a particular amino acid, which is very, very interesting. I also am going to include a full feature on this amino acid because some of the research I've discovered on this amino acid is just absolutely mind-boggling in relation to health, in relation to fitness, and it's just about unknown. Most doctors could tell you nothing about this amino acid. Even many biochemists aren't that familiar with this particular amino acid. And the amino acid that I'm talking about is called taurine. Taurine is derived from the Latin term for bull because it was originally isolated from ox bile. So taurine is kind of Taurus is the word for bull, so they called it taurine. Most people, if they're familiar with taurine at all, they probably associate it with a very, very popular energy drink called Red Bull. Well, Red Bull contains 1 gram of taurine per 8-ounce can. That's a pretty good amount, actually. That's not bad. Now, why is taurine in Red Bull? Red Bull, of course, is a stimulation drink, and it has a decent amount of caffeine in there. Some people might find the caffeine, especially if they drink several cans of Red Bull, it might have an overstimulation effect. So they added taurine to the Red Bull drink to counteract the overstimulation that can be induced by the caffeine content. I'll explain later on in this video how taurine is able to do that, but I just wanted to mention why taurine is in Red Bull. Okay, as I said, taurine is considered an unessential amino acid because it could be synthesized in the body. It's classified as a sulfur-containing amino acid, and it can actually be synthesized in the body, mainly the liver, if you ingest 2 other amino acids, namely methionine and cysteine, both of which contain sulfur. However, in recent years, they've become aware of the fact that this let's say, endogenous or in-body production of taurine is not quite as efficient as they thought. In other words, you can make enough taurine from those other amino acids to not be more or less deficient in taurine. However, you're not getting optimal amounts. On the other hand, taurine is found naturally in a lot of protein foods, and it's particularly concentrated in fish. As a matter of fact, some studies, you've probably heard that fish is very good for preventing heart disease and all that. And a lot of the reasons for this are attributed to the omega-3 content, omega-3 fatty acid content, particularly in fatty fish like sardines, herring, and mackerel. But other studies have looked at it more carefully and noticed that even if you remove, let's say, the omega-3 fatty acid content of fish, fish still offers protective effects against cardiovascular disease. And what these scientists theorize is that it's the high taurine content of fish that offers a lot of the protective benefits. So fish actually is protective from 2 points of view. It's rich in omega-3 fatty acids, that is fatty fish, and it also has a good content of taurine. Now, I'll explain again later on why taurine helps your heart. Taurine, by the way, is the second most abundant amino acid in muscle. The most abundant is glutamine. 60% of the amino acids found in muscle are glutamine, and it's followed closely by taurine. Now, nobody really knows why so much taurine is found in muscle, but through my experience of studying research for over half a century, I've noticed a pattern that nature never does anything for no reason. In other words, there's always a reason why something exists in certain tissues or whatever. So taurine obviously does have an important function in muscle. And again, later on in this video, I'll explain what these functions probably are. But I should also point out that taurine is not involved in muscle protein synthesis. As I mentioned earlier, the amino acids involved in muscle protein synthesis, which is the cornerstone of building muscle, are the essential amino acids. There's 9 essential amino acids. The most potent amino acids in that respect, as I mentioned in previous videos, are the branched chain amino acids, with the most potent of the branched chain amino acids being leucine. But I've discussed that before. I don't want to get into that again. Otherwise we'll be talking here for hours. But taurine, your body has an amino acid pool. In other words, when you consume proteins, foods, it's broken down into amino acids, as I said, and some of them is stored in a temporary amino acid pool in the body. 3% of that pool is taurine. So it's another interesting thing about taurine. Again, as I just said, the nature does not do things haphazardly. There's always a reason for it. And I find it interesting that taurine is the most concentrated amino acid in the testicles. Now, what does it do in the testicles? One of the functions of taurine is a very potent antioxidant. It's an antioxidant nutrient. And your testicles, of course, this applies only to men. But anyway, the testicles are constantly assaulted by what they call free radicals, which are byproducts of oxygen metabolism. Eventually cause destruction of some of the cells in the testicles, particularly the Leydig cells, where testosterone is synthesized from cholesterol. So what happens after many years is that the Leydig cells don't function right, and this leads to what they call hypogonadism, or low testosterone in men. Usually hits men about 40. Where does these free radicals come from? They come from normal hormone circulation within the testicles. For example, catecholamines, epinephrine, norepinephrine. These are hormones your body's always producing. Unfortunately, have a side effect. They tend to increase localized production of free radicals, which damages tissue. The existence of taurine in the testicles can soak up some of these free radicals, prevent the damage. Lycopene is another nutrient that's concentrated in, lycopene is found in tomatoes and red vegetables and that kind of thing. Lycopene also provides an antioxidant activity in the testicles. In animal studies with rats, they've shown that if you provide them with antioxidant protection to the Leydig cells when they're fairly young, these rats do not develop low testosterone. They never do. They die of other things, but they do not show excessive aging of the Leydig cells. So my theory, again, I don't have anything to back this up, is that taurine will actually help prevent or help preserve your testicular function, based on the fact that it's very concentrated in the testicles. Anyway, in the joints, taurine also provides a protective function because it prevents the premature breakdown of hyaluronic acid. What is hyaluronic acid? Simple term for hyaluronic acid is joint fluid. It's a fluid that's produced in the joints that lubricates the joints, prevents the joint linings from rubbing against each other. If the hyaluronic acid dries up for any reason, you have arthritis and you have joint pain. So again, taurine will prevent the premature breakdown of hyaluronic acid, thus possibly, again, not a lot of evidence for this, but based on the function of hyaluronic acid, there's a possibility that taurine might help prevent arthritis, especially as you get older. Another really great feature of taurine is that it has a potent blood pressure lowering effect, or an anti-hypertensive effect. How does it do this? It appears to do this by modifying the effects of what they call pressor hormones. These are hormones that kind of tighten your blood vessels and raise blood pressure. An example of this is norepinephrine, which is actually your body secretes under stress and also exercise. But it also tends to cause a little bit of elevation in blood pressure because it constricts the blood vessels. Taurine will help to modify norepinephrine, thus helping to control blood pressure. An interesting animal study showed that animals that were giving anabolic steroids, if they were also provided with taurine, they didn't show any elevations in blood pressure, whereas animals given the same steroids and not given taurine did show elevations in blood pressure. So, although this was an animal study and it may or may not be applicable to humans, it might be a good idea for those who use anabolic steroids to consider also using a taurine supplement to protect against any hypertensive effects induced by the steroids, because steroids do tend to cause an elevation in blood pressure due to certain mineral retention such as sodium. So it's a good idea for steroid users to supplement with taurine for that reason. Taurine, as I said, it's not involved in actual muscle protein synthesis as our essential amino acids, but it does have an indirect anabolic effect because it's what they call an osmotic amino acid. It tends to draw water into the cells and increase what they call cell volume, or the hydration level of cells. When a cell is hydrated, it tends to send out anabolic signaling factors that result in increased muscle protein synthesis. So in that respect, taurine can be considered a kind of a semi-anabolic amino acid. Glutamine also does that, by the way. Insulin does too, but that's another story. Animal studies show that, as far as muscle contraction goes, I should tell you right off the bat, the exercise studies on taurine, which I will discuss in depth in my feature on taurine that's upcoming in my Applied Metabolics newsletter. A lot of the new findings about taurine are way, way too extensive to be discussed in a video like this. If I did, the video would be about 6 hours long, and I'm not exaggerating. That's how much data there is on taurine. But I can tell you that the data on the exercise effects of taurine is mixed. But one thing that taurine does do that could probably help with exercise is that it increases the efficiency of the use of calcium ions within the sarcoplasmic reticulum section of muscle. In simple English terms, what this means is that ingesting taurine will help your muscles contract better. You'll get stronger muscle contractions, which translates into possibly stronger muscles when you work out and less fatigue. As I said earlier, taurine is very important to heart function. And if for some reason you depleted all your body of taurine, you would have serious defects in your heart muscle function. How does taurine work in the heart? Well, besides regulating calcium, it also regulates other electrolytes or minerals that are vital for the function of the heart, that's actually needed for the heart to beat and function properly. And taurine helps to modulate and balance the existing electrolytes or mineral content of the heart. So it's extremely important in that respect, and it may, in that respect, help prevent abnormal heart rhythms or arrhythmias. So again, taurine is very important to the heart. I will be going into a lot more mechanisms about how taurine affects the heart, including how it affects lipids like cholesterol and triglycerides in my article that's going to be in Applied Metabolics newsletter on taurine. Taurine also has effects in the brain. It induces a calming effect in the brain. It helps you to relax and helps you to sleep. It does this by interacting with what they call GABA brain receptors. GABA is a kind of an amino acid byproduct. It's also made from amino acids like glutamate. And in the brain, it's the primary inhibitory neurotransmitter. And taurine seems to interact with two GABA receptors in the brain, GABA receptor A and B. And when you interact with these receptors, you calm the brain and it helps you relax. and it helps you to sleep. As an aside, because of this function of taurine, I use taurine myself as a sleep-inducing nutrient. Every night before I go to sleep, I ingest 3 grams of taurine, and it works very, very well to calm me. And within about 30 minutes, it actually helps me to sleep. So it's a very excellent calming amino acid. Uh, interestingly enough, uh, because it also it affects what they call opioid receptors in the brain. Taurine in animal studies has been shown to stimulate growth hormone release. I'm not sure how this would translate to human physiology. I don't know if there's been any. I don't think there's been any direct studies on the taurine effect of growth hormone release in humans. It probably does. How much and when to take would be very difficult to answer. Nobody's really studied that. I do know that taurine does increase insulin sensitivity, which would have a beneficial effect related to fat loss, and also in prevention of type 2 diabetes. I'm going to be discussing a lot of the effects of taurine. There's been some human studies and animal studies on how taurine affects body fat accretion. I'll be discussing that in extreme depth in my Applied Metabolics newsletter. Just talking about that aspect of taurine alone would take about 2 hours. So I'm not gonna. I know that a lot of the people watching these videos unfortunately have about a 4-second attention span, so I wouldn't even try to do a 2-hour video. In fact, why are you people with 2-second attention spans even watching this, for crying out loud? Stick to your comic books. Anyway, taurine also, as I said, it helps to prevent body fat accretion, and I'll get into that in my article, and diabetes, which I'll also explain the mechanisms. And what about this? What's the safe dose of taurine? The studies that exist, there's not a lot of them, show that you can take up to 3 grams a day, which is what I take. I sometimes go to 4 grams, depending on if I'm a little bit nervous or something like that. I might pop a gram of taurine just to help calm me down. Never had a problem with it. I've discussed in a previous video that there's a little bit of an antagonism between beta-alanine and taurine, but it doesn't really exist, because you'd have to take massive amounts. If you did somehow take gigantic amounts of beta-alanine, like 20 grams a day, first of all, you'd have a side effect, a paresthesia, as I mentioned. Your skin would feel like it's burning in hell, which would make you insane to begin with. But if you did do that on a consistent basis, you'd probably wind up with some heart problems. But you'd have to, again, be a complete lunatic to do that. So it's ridiculous to even talk about any further. So as I said, I'm going to be talking a lot more about taurine in an article coming up in my Applied Metabolics newsletter. This video, I just wanted to show you some of the interesting aspects of this little talked about amino acid, which I think is really one of the unheralded champions of nutrition, taurine, which nobody really talks about. It's not a superstar amino acid like leucine and branched chain amino acids, but it does, according to my research, which I will explain in my article, I think you'd be very, very impressed with taurine. In fact, when I first wrote about taurine in a bodybuilding magazine about 15 years ago, I never even considered taking taurine, but I was so impressed. That's when I started using taurine. I've been using it ever since. Anyone who reads about taurine is going to think twice and is going to say, wait a minute, I need this stuff. But again, I'll explain all this in my article in Applied Metabolics newsletter. And besides taurine, I talk about all aspects of nutrition, fat loss research, anti-aging research, exercise science, hormonal therapy, anti-aging, ergogenic aids, all in depth, way, way more in depth than you'll find on any internet blog or website. It's all evidence-based. I call it Applied Metabolics newsletter. It's actually a monthly ebook averaging 40 to 50 pages. And as I've said in previous videos, if you subscribe to my Applied Metabolics newsletter and you read as few as 6 issues of it, I guarantee you will be your own expert and you will know all there is to know about anything you read about, to the extent that people will now be asking you questions when they realize, when you come up with some of the stuff that I write about, people will be impressed, because very few doctors, nobody knows this stuff. except the scientists that did the studies, and they don't generally talk about it. So you can subscribe to my newsletter at www.appliedmetabolics.com. I do answer questions, brief questions from my subscribers. There's a email portal on my Applied Metabolics site. However, I should also point out that my response to questions are exclusive only for my subscribers. I do this in appreciation of the fact that they support my work. I do not answer unsolicited questions. In other words, if you view these videos and send me a question and you're not a subscriber, I'm sorry, I'm not going to answer your email. I only have a limited amount of time, and I want to reserve that for the people that subscribe to my newsletter. Thank you for listening. And for crying out loud, go to a shelter and get yourself a dog. I mean, they'll protect you against the Trump administration. Take care.